Hey everyone, I just moved into a new place to be closer to work and it's like 1 in the morning right now, so I thought there'd be no better way to celebrate my move than to share with you an example I came up with a few weeks ago when I was trying to explain the concept of entropy to a friend of mine. Now, for those of you who may recall, from a statistical physics perspective, entropy deals with the number of microstates a given macrostate has in the context of thermodynamics. Now, I don't really want to get into the weeds of this. I just kind of want to show you an example that I think gets the essence of entropy across fairly well, and I'm curious to know what you think. So let me turn the camera around here really quickly, and so I can actually see. Let me flip this a bit. Okay, so let's look at these cards here. I have the 2, 3, 4, 5, and 6 of spades on the table in front of me, and I'm just going to call this a macrostate. This ordered set of 5 cards is a macrostate, and it only has one microstate because there's only one possible way to have all these cards in order. So from an entropy perspective, this is a low entropy state because there's only one microstate to it. There's only one way we can get this arrangement. Now let me bring in another set of 2, 3, 4, 5, and 6 of spades here. And I'm going to define a new microstate, or I should say a new macrostate, sorry. Let me just take away the middle 3 cards and say this macrostate is the macrostate where we have the 2 at the beginning and the 6 at the end. But the middle 3 cards we can rearrange in any order that we choose. So we could have the state like we had above with the 3, 4, 5 order, but we can also have 3, 5, 4. We can also have 4, 3, and 5. We can also have 4, 5, 3. We can have 5, 3, and 4. We can have 5, 4, and 3. So there's 3 distinct objects, so there's 6 ways of rearranging them because that's 3 factorial. And we would say, in a thermodynamics or statistical physics sense, that the bottom macrostate has a higher entropy than the top macrostate, because the bottom macrostate has 6 different microstates, because there are 6 different ways we can arrange these cards. But the macrostate where they're all in order only has one possible configuration, and so it has a lower entropy than the macrostate on the bottom row. Now, another way to think about this is that if we just sort of took these cards and I just sort of threw them out like this. That was a really bad throw. We don't have 2 and 6 at the end. Let's say, for example, I did. It'd be much more likely to get this configuration, the bottom configuration, or the bottom macrostate, I should say. It'd be much more likely to get the bottom macrostate with 2 and 6 fixed, but the 3 cards in the middle rearranged, than the macrostate of having them all in order, because there are 6 possible ways we can get 2 and 6 fixed and rearrange the stuff in the middle, but there's only one possible way to get everything in order. So that's the example. I hope it kind of illustrates, at least from a statistical perspective, what entropy is, or how you can sort of compare 2 different states of entropy. So with that, that's the end of the video, and let me know if you liked it, and I'll try and make more videos like this in the future. Take care.